What about others? Are they coming? Yeah. Coming, quick. 早上好。没过。
And the gross one comes. I don't know, I think the weather.
That cold? I don't think it's that cold.
You think that
It's so cool.
This
is so cool.
Yeah, so cold.
Good. Even to drive.
It says it will snow maybe during weekend.
I think no.
That's what, yeah, the weather forecast is.
The weather forecast says it will maybe snow.
Why the AC not working?
You can just turn on. It's okay.
Actually, 2 days ago, it was 1 degree in the morning. Hey, so it's a possibility. I'm not a fan of the cold. It makes me feel sick. Yeah.
Yes.
Show me the dad. Show me the dad.
Is this one?
Yeah, he did.
Yes.
So he did.
I think if you put this one and this one, you will multiply the five.
Yeah, that's right.
You will multiply the five. Because this.
Okay, let's get started.
For real.
Yeah. Exactly which page?
Today I bring my laptop to show you guys some knowledge about how to use Matlab to do simulations. Okay. Okay, first let's recall the memory about transfer function. So first, what's the definition of transfer function?
Transfer function is the ratio the output the
Outputs over
input of
just
the Laplace transform.
yeah, that completed the Laplace transform, then you got the output over input, and you got the transfer function about to see right? And then how to show a transfer function in MATLAB. How to build a transfer function in MATLAB then. So here are some codes we should use. First, do you guys know how to write in like matrix in MATLAB? Matrix.
No, we didn't do MATLAB.
Okay, here let's see a example here. Okay. Maybe here it's a output input transfer function. here is a transfer function, the form like this. Then how to write in this into Matlab? Matlab, it's if we want to write in a transfer function into Matlab, then we need to deal with separately about numerator and denominator. You should first define two matrices. One is about numerator, another is about denominator. Let's see. Just say name a matrix about numerator and another matrix about denominator. Then we should be write in to this. We should write in the what? The coefficients about S or S orders according to the decreasing order of the index of X. So here, how about this? We have a what? A number here is 2, right? How about the first order? S, what's the coefficient?
0.
1.
1, right?
Okay.
So the numerator matrix for this one is 1, 2. This S plus 2. And how about denominator for the matrix for
5, 1, 1. 5, 1, 1, 1.
500.
500.
0, 0. So 500 and then what?
1,000.
1,000 and 1
1.
and
1.
1. The last should be what? Just the number, just the constant, constant, right?
Yeah.
And then according to the decreasing order of S, right?
Yes.
Then what if no S here?
You put 0. You put 0.
Then what's the denominator now be like?
500,000.
500 still,
1,000.
and 3, 2, so this is 1,000. And how about
0.
S0, S first order of S? 0, right?
Yes.
Because no S here. So constant coefficient for S to the first order is what? 0. So you should write 0 here and what?
1.
Constant. So this is the way we name out the numerator and the denominator matrix in Matlab. Then how to type in this? It's easy, right?
Yeah.
Just type in now 500, 1,000, 1 and 1. Oh, this is denominator, right? Sorry. Then it shows the result. And we type in the numerator. It's what? 1 and 2. Then what code should we use to connect them together to get the transfer function?
Division code.
Yeah, there is a code called this code means what? You get a transfer function by connect the numerator and denominator. You just type in. But then you need to name the system first. So maybe we can call a system equals to the transfer function, including numerator and the denominator. We just type in. So the code should be like sys equals this GF now and then let's tap enter to see what it would be like. See here, it shows a transfer function just the same we have, right? And it says it's a continuous time transfer function because it's a Laplace transform, right? So this is the system we just need. So easy, right?
Yeah.
Okay, then how about sometimes the transfer function we have is not in the form according to the decreasing order of S. maybe it's in the form maybe like this. Let's see here. Maybe we got a transfer function. Let's see here, maybe in a form like this. Let's be factorizing. And we see the numerators. Actually, we call like what number makes s plus 2 equals to 0. That is called what? Remember? Zeros. The value that lets the numerator be 0, and that is called zeros. So for this, how many zeros for the system? How many zeros?
5.
Zeros.
0.
The value make denominator equals to 0.
1.
Then the poles. So zeros
zeros
and the poles.
zeros are 2.
-3.
So zeros is -2, -7, right?
Yeah.
And how about poles?
-3.
-3, -7, -9. Right?
Yeah.
So this is what we can read from the transfer function information. And still we have a constant out of the whole 2. So what is 2? We treat 2 as a what? What a typical link? 2. We can treat 2 as a yeah, it's a constant. So we call a typical link the form of a constant is what? Proportional link. Remember? So this is we can call this is a proportional constant or again. So we name it K. We usually use K to means again means what? Proportional constant. So the K for the whole system is what? So what we can read from transfer function, the information we have is there are 2 zeros in this transfer function, -2, -7, and there are 3 poles of the transfer function. That is -3, -7, -9, and another constant or another again K here is what? 2. Then how to type in the transfer function? Let Matlab show this.
Let the name is used.
Matrix form.
The poles in the matrix form. Is the CF function.
The first 3 steps, all right. But the last code we use not the same. TF just means the numerator and the denominator are in forms like according to the decreasing order of S. But here we just in the form of zeros, poles, and K. Then another code should be used. Then first, still we name zeros. Maybe we name a matrix Z like this. It means this system has 2 zeros, -2, -7. Then we can name another matrix P, means poles here. Right? We have 3 poles here, right? And then name another constant equals K equals 2 means we have again out of the whole. And then what code should be used? Here's a new code. Previously called it what? TF, right?
Yeah.
This time we need code. Easy. Just ZPA means this transfer function is in the form of 0, pole, and get. So ZPA should be Z, P, and K. And still, we can name the system. Let's try this, okay? Oh, here is a quick code to clean up the common windows. It's
Yes.
you know that?
Okay, z equals to what? -2, -7.
-9.
Okay, we have 2 zeros. And how about p? -3, -7, -9, right?
Yes.
Okay, we have. And then we name a gang here. And we want the transfer function in this form.
The same.
Right?
Yeah.
Totally the same. So we can deal with two forms of transfer function. One is in the form of to the nth order, right?
Yeah.
And another is in the form that consists of zeros, post, and get. And here comes the new question. What if the whole system, maybe still the post remains the same, but maybe the system now changes into system has no zeros. Then how to show up the transfer function? What will change?
We remove the C.
No z?
Yeah.
Totally non-exist?
We can make this 0.
What? You mean maybe 0?
Yeah. Or we can take off C and use PK at the code.
You think? Here is the special problem. Maybe we will miss. Maybe sometimes the system has no zeros. It does have this kind of situation. So how to use ZPK still to write the transfer function in Matlab. So let's see, since here's no zeros, we still need to name a matrix of zeros. But does it have value here?
No.
We just leave z in there. So this code means the system has no zeros. But it is different from this. If you write a 0, it means it has a 0 and the 0 value is 0. So if a system transfer function has no zeros, you just leave nothing here. So let's see. We just leave nothing here and then still use the system. Still use ZPK, but now Z is changed. Other things remain the same. So use sys equals ZPK. Showing up here. Is the same with this? But if you write a 0 here, let's see what will change here. If we will write a 0 and then still use this code, other conditions are the same. See here, we have 0 here, and 0 is 0. So if there's no 0 here, you should be left to nothing in that code. Now, this is the problem we may be facing, so you should treat it. You should fix this. And then, now, and sometimes the problem is like, okay, still. We still use the down here. And now, how to change this form into the form that is in TF form, like according to the order of S. And how to, this is DPK form, right?
Yes.
And how to get TM form on of the same system.
TF form.
Yeah. Just if we do math, we can just do the math right, like s squared and what? S and working right? We can do this by hand. But how to do this in Matlab? How to change AGS in ZPK form into GS of TF form?
And we can use the code TF backend. CPK.
Okay, here, let's see. So we need to back to the system we have here, right? We have a system like in this form.
Yeah.
Then we want to change it into the form that in the transfer function TF form. Here's one code you can use. Maybe we name the system 2, maybe system 2 equals ZP2. 2 means same pronunciation. Means 2.
Oh,
2 what?
to TF.
2 TF. And what conditions you have right now? You know D, you know P, you know K. And now here maybe we name another system 2 equals the transfer function from DPK to TF. So let's see.
Actually, why didn't you add Z to the PK? Why didn't you add K to this GPK?
Just ZP, the code says just ZP, no K here, but here shows the K. Oh, let's see. These two, oh, sorry, Z must be off. Z must be, we name it and we need to do a ZP2. So here, what's the, oh. Okay, here. Sorry, I forgot one more step here. This code means you get what? By using this, you cannot just get system transfer function form from this code. What you can get is two matrix, numerator matrix and denominator matrix from this. And you see here, by typing this code, we know ZPK here, right? And we from ZP to transfer function. And we have two matrices, numerator and denominator. And what? Use which code? Right? Is this right? Is this right? We can compare it to, we can just do it by hand to see the results, right? Okay. So here should be 2s squared.
18.
Yeah, and the how about the so this, yeah, the same, right?
Yes.
So from the form ZPK to transfer form TF, there are two steps you need to process. One is what?
to get numerator and denominator for TF by this code. As long as you know the D, P, and K, right? And once you get numerator matrix and the denominator matrix, just use the code TF to get the system transfer function in form of TF. Then, how about now you know the how about at this time, firstly know the TF form, then how to from TF form to ZPK form. The code should be what? Just the opposite. It's what? TF, right? No K.
Okay.
No K here. I don't know why, but no K here. But ZP it also means ZPK, but just no K showing the code. I don't know why. And what should be used?
Numerator.
Number and denominator. So first you know the numerator 2, 18, and 28, right? And denominator is what? 1, 19, 111, and 189. And you type in numerator and denominator for the TF one. And then use this code. And then you will get what? D, P, and K, right? So I use this code. You get a matrix of zeros, poles, and K. And then what next step you need to? 2 or 3, as you like, okay? Equals what? And here we have K. I don't know why, but code is right. So from TF to ZPK form, still 2 steps you need to process. One is to get ZPK matrix by the code TF to ZP. Once you have the matrix, then use ZPK code to get the transfer function in ZPK form. Okay, we have rest.
Send the link. You want the link?
No more.
Yeah, yeah. Yeah, so it's bring the cash. Where's the cash? That's share information. Sunday is not a school, guys. So
Your country never snow.
country doesn't snow. Why did you want to
We 2 times.
Hey.
Probably 2 times.
Yeah.
The provinces in the north.
Every year.
No idea. Like what? It's happening. I think 7 years ago. Yeah, 7 years ago. It was like something strange. Yeah, it was strange. No one would believe it. Just one house.
Sure, I know someone just talk about it.
That province is so close to the ocean. I just bought do things for yourself. When you have this mindset,
How does it mean that you are like that? How does it mean?
no, like,
Ouais, j'ai une de homework. Une de homework. Ouais.
I am the one more
Regarde ça, lui.
Ajá, Laura.
Habla.
Ven.
Habla.
Ven aquí.
Habla.
Ven aquí.
Eu não vou ver.
Tengo que decirte que
Eu não vou venir.
Tengo que
Eu não
ver.
vou venir. Como é que você tem a ganhar?
They don't put you around the street, just stop.
She wanna order me.
No, if someone from your country were here also, you just do the same thing.
If your mother don't show up.
Oh no, if they don't speak that, their own language, they will say, this, that, it's not that they say,
We are
I
speaking
say,
English.
word, things like that.
We speak English.
Like this.
But,
Huh?
I don't know the story, bro.
Bro, all of us, we got this different way to solve it.
So
Especially the last one.
the teacher say it's good to be wrong in an assignment, but it's not good to be wrong in an exam.
Okay,
The
now
thing
this is.
is that the good thing is that when we do the assignments, just to correct here. Everything we correct.
Oh, when we,
That is why she said doesn't matter the assignment, it's not good, but
the
it
most
matter
important
the
thing
exam.
never miss to sing a song. He said,
Yes.
if it's not,
Even
if
if
you're
it's
not
good or
sure,
bad,
but
but
make,
don't-
if
never
you're
miss
not
it.
sure, but make
Just do
sure,
something.
you're sure that you. I mean, you think to that you are dependent on your husband. For real, I'm becoming like that. If you are becoming fat,
It's fat.
be careful.
Don't mind, mind.
Show me the
You go back. Se eu me, espera aí, eu vou falar. Eu vou falar. Se eu mirar que teus peitos estão aumentando e eu vou tentar de volta para o país.
Okay.
Tentar de volta.
Okay.
Ah.
This guy is like that, don't mind. Go get with it. Push him out.
What?
You see,
I
you
will
see, you
put
see what's
that in,
happening
you
with
will
the
have
weather?
in my paper, I can't take it there. There's no answer. I didn't do.
You see what's happening to the weather? Because of this weather.
I'm saying that.
What's
I don't know
it?
when you say that. I used to because I used to.
You're not the only one. Somebody will do this week, especially when you
No,
lose sport.
but last time I was more better than
The thing is, if you like,
You can take care of everything.
you and him,
Hey,
you are
what's
the
the-
father.
Not bad.
What did you tell me?
Hey,
that?
not bad.
Not bad.
Bad.
Not
It's
bad.
not
What
support.
did you
Sometimes you're
He said if you
This
get somebody
is
to go back
just
to that.
analysis. This is just analysis. Grammatically.
My God, I'm very smart.
Hey, I want to do like you.
Grammatically.
All of you are the same, all of you.
Grammatically.
My family, they are just big people.
Okay, that's fine.
I was seeing this, even when I
Yeah, but even in the moment of coronavirus, bro.
I was so slim,
Hey.
more than
Me and my
one.
family, all the ladies.
After like the 1 month with some weeks, I'm going to the second floor. I just saw some money coming. Who is this? Go, bro. I said this girl will disappear. The girl is so sweet.
I was just spaghetti,
One day,
spaghetti.
then I was going to give some
That is
Move.
why.
The people think apple is a good food. Eat apple make people become sick.
Yes, I was
Then I went to the- I went to knock her door.
Yeah, I was eating.
Then she opened. No, when I saw it, I was like, what?
If
This
it
is when I changed it, but saying it,
this
no.
stuff, for us to see someone who has
Who
it,
said so?
you will see this
For
stuff.
me, I saw it the first the first time I knocked her door. It was like 2 months and I was waiting. I went to the first floor.
I wasn't even going out. The only person who knew that I was in that.
You didn't go out.
It was my countryman, Joshua.
But why were you
Because
always
every
inside?
time, every
knew he
time
was there.
Joshua
I
was
also
coming
knew
to
you was there.
even when I was sick, he was going to even ask someone for.
The question is, why were you locking yourself inside your room? Go ask come. That's
So-
you were scared me have it, so you are locking yourself in your room. So I don't need it.
The day when some people cried, she came to my room that day.
I
He
told you
was
that.
talking like he wanted to open. And then when he opened, when I opened the door, he said, I thought there is no one here.
My
But I was dangerous. Don't do that.
bro. That
You
guy,
need to
my hands
confine
mine.
yourself. in your-
Imagine at that time, I wasn't there. I wasn't having.
Yeah, she was sick.
And then when I was having,
And
I
she
was
was
having
like,
a lot of
"No."
money, but the thing that I was having money, but not. The only food I was having, whenever I was to buy food, I always buy a lot of, like a bag of rice, things like in lot of quantity. That is what made me that when people were asking for food, I was still having maybe some rice, things like that, but not a lot.
At
After
that
that,
moment,
I started eating just all of my spaghetti, just
Yeah.
spaghetti, just
Me that moment, I was enjoying myself.
even I wasn't even telling my country.
Me,
They
my
didn't know that I
You know why I was enjoying
Also,
myself?
one guy from one province, bro. The guy arrived today. The same day he's going to my room. They are eating together. I just told the guy is coffee. Price out now. Right, come.
You didn't know.
No, my country didn't know that I was there and I was passing all those things. And then they
Everybody,
started telling me that no,
when you
how
come
can
to my
I
room,
do like
gotta
that?
wear
They
mask.
were here with.
If
They-
you
I
don't
should
wear
not
mask,
fall
don't
down.
Me,
come.
I was like that. I was always in my room. And learning that time I started learning HTML because there was a guy in my country. He's a doctor, he has a PhD, and he went to Colombia. And in Colombia, he has some deals he gives. Because he went to my high school. And he was our
I
teacher.
don't sell drugs.
So he's giving us deals like to make codes for parts of applications. So I had to learn HTML. I was in my room, I was like, I need to get this money. Imagine the motivation.
No,
So I was in my room one day, Daniela came.
when
You look so white. So I'm just eating noodles.
No.
Oh, let's go.
You see,
I went to
you see
Ghana.
beans. I was eating cold beans every day.
I was being serious.
Me, Daniela was cooking every day. I was,
They-
me, I was just eating.
That moment I realized, no, always you will choose what you want to eat. Bro, morning spaghetti, afternoon spaghetti.
Like every day it was like that. And then that's when they started buying things for people. I was buying, I don't know, but every day I was the one that having a lot of things. Because I was buying a lot of things. I was just saying that today they're buying things, maybe all of them. I was just buying things. The day I told my mother asked me to wait myself because when I called her to she saw me, she was so scared. Then she asked me to wait myself. And then she was like,
You guys didn't know the deal. No, there was this Chinese guy.
The staff, yeah.
Oh, bro.
I knew you guys
I
never.
didn't know.
How did these guys get this business? One day, ask my room. Bro, I can show you, I can link you up, man. He took me to the vegetable. I took another vegetable. So when I bought the vegetable, I was just enjoying myself. Before Corona came, I and Daniela went to fish to buy chicken and beef and go to the Ghanaian party. And then when the Corona hit us, they were like, we tell them we didn't go to Monshi. Yeah. So the people thought we went to Monshi. And then we bought it. So we gave them back the money and we told them. So we had the chicken.
Me, the guy I
We're
said,
just eating.
don't come to my room was Jonah. You see, Jonah, during Corona part, everybody on every school will cross. Hey, bro, bro, he's getting in the
I
hand.
had the same problem with Brian.
Everybody will go to breathe. I said,
This guy went to Google, came back. The guy could not see. My back. My chest. Imagine at night to go and come like the roommate shouting, oh my back. My chest.
Every day,
Martin,
every day.
ask Martin that is knows with the cloth.
Hey,
Carlos was scared. He went to sleep in
I was so scared.
Even this guy, some people was going to the
Yes.
Of course.
they will
Brian,
jump.
they were going.
Go some Brian.
You are talking that he wasn't in my room.
So this guy will kill me for real.
No, but now I like how I'm not fat, not slim. Not like
Hey
that.
bro, I lost my way for real.
But me during Corona, I didn't see any change in my body because I was already sleeping.
Yeah.
I was not working out.
For real.
I've never been fat, but
And I don't know why. I think the problem that makes me slim or fat
Was a thing.
mine.
Yeah,
yes.
Because me,
You know,
me,
there were
in
a
my
time
church,
I wasn't sick, but it's like just because I was just having that in my mind, thinking about it, I was just feeling all the symptoms of
me, I didn't feel anything. You see high school, how is your high school like? In my high school, you don't go out. The day you
No,
enter
every day you go.
the day you enter the school, 4 months you be in the school, you don't go out until vacation. You can't even go to the door. There's a white school, they paint it every 2 weeks. You can't cross that line. Who are you? Hey, Mr. Joker.
By that moment, by that moment, Mr. Mom was like a father for us. Nah, I gave her the
You know, he went to Malaysia. You know when he came back? Hey, you go to the school for this. Take a break, go into class. Came back.
So it was. All the beans. That beans has a sugar.
me. That's what I'm saying. What I passed through that time,
I'm just imagining what was intended to children alcohol. Hey, my son also.
I
But
it wasn't a good experience. I can't understand. I feel like if I told them about it, I can't tell them.
you can't. They'll ask you.
Okay, let's see from here.
Actually, in the real field of work, people calculate with their hands anymore.
Sorry.
In the real field, where I have to work, control system, do people calculate with their hands anymore? Or just use something?
Of course, use Matlab or use computer to do math.
Oh.
Because the math, the system, math is getting more and more complicated. Math, we just can't deal with hands. So Matlab, of course, do simulation.
So actually, our exam to have MATLAB.
What?
Our exam. You have some MATLAB tools.
Yes, but Matlab courses are or experimental course.
I mean, the exam for this course, we have some MATLAB.
Yeah, because there are 2 courses we need to do simulation by using MATLAB in lab. Right?
Yeah, but I mean, in exam,
Our exam.
Exam.
That you give to us.
we use MATLAB to do something.
Oh, no. Exams only including the knowledge in the textbook. Yeah.
Oh.
Yeah. This is the extra knowledge to help you to do simulation in lab. Yeah, because I think it's very useful.
Very useful.
Okay. Okay. Let's see some windows in MATLAB. First, the biggest one, comment windows. You can just type in the code, and by tap the enter, you will directly show the results of your last code you just typed. And if you add, if you see here, if you add little this, then by tapping enter, no results showing up. Why?
So that's the result when it's going to run.
No results showing up. But is this code running already?
No, it's not right.
It does run. It did run, but no results showing up. And the results, the results by this code, it's saved here. See here in workspace. Workspace is all codes you just run. Whether the results is showing or not are all restored in workspace. See here, the den, K, num, P, C, 2, Z are the code we just run, and they are the results here. And here, another window says what? Comment history is the comment just used. Because this will be scrolled up and down, and it is hard to locate one comment you just type in. And you can just search those comment in history, this window. And this is current folder, is the path we're in right now. Okay, this. And we just talk about transfer function in two forms. One is the APK form, another is TF, right? And sometimes, let's see here, sometimes we need to consider about not only one system, maybe two or more systems they are connecting. There are some of kinds of connecting we learn. First one is what? Connecting. In series. Okay, 1 and 2 in series. And then parallel. And feedback. So, if now we have G1, G2. This is in and out. And if we give you G1 as like S plus 2 back as 2 and 3S and 10. And G2 is just 10 S plus 1 plus 2 plus 10. Then if we consider these two in series, how to get transfer function for the whole out over input. If we do by hands, it's easier. G1 times G2. But how to use Matlab code to do the in series connection for you instead of you do by your hands? First, of course, you should type in these two systems into Matlab. And then, okay, first how about this and this? How to type in? G1, start with the numerator, okay? We name numerator 1 here. What is the numerator for the first G1? 1 and 2, right? How about the denominator? 1, 3, 10. And here, what code should we use? G1. Maybe. No. TF. Num and then. And num1, then 1, right? This is the G1. Okay, then how about G2? How to type in G2? Numerator 2 is just 10, right? How about the denominator?
10, 1.
And then use the code maybe. Okay, now, see we have G2 here and G1 just here, right?
Yeah.
G1 and G2 are all stored in workspace, are stored in here, right? We have G1, G2 here, right? Then how to do connection in form of series, in series? Of course, there is a code to do. It's very easy because you all speak English.
Yes.
So code is just abbreviation for one meaning of a vocabulary word. So using series, so the code is just
SRS.
SERIES series. Easy, so easy. Maybe it's hard for Chinese students to learn code because they firstly should know the meaning of the vocabulary and then use the code. But for you guys, I think it's so easy, just series.
Yeah.
Okay, here. Maybe we call the whole output in over input transform, we call it just upper G, okay? So G equals to what? Series for what? G1 and G2. Easy?
Yeah.
And you can do by hand to see if this is right. Of course, it's right, okay?
Yeah.
Then how about in parallel? What's the code? Guess what's the code? Easy?
Yeah.
Just parallel, right?
Yeah.
So if these are changed into the form, then what?
Parallel.
Hmm? You should just change. Maybe we name it like GG, okay? Another GG. Final transfer function is just what?
Parallel.
Parallel. Easy?
Yes.
Easy.
Easy.
So easy.
Done.
Okay. So you know how to do in series and in parallel. How about this? And now it's a what? It's a feedback loop. And it's a what? Negative feedback. If we want to get the whole transfer function from out over input, maybe we name it this, okay? Now this here, then how to get the transfer function of
Negative feedback.
negative feedback?
Not G, yeah. G on G.
G1
Minus,
You get
no,
just
no.
one block.
You should first identify it is not in parallel, it's a feedback.
feedback.
What is the difference of parallel and feedback?
Feedback is connected to
Parallel form are connected in the same direction. But feedback is what? One direction is to output, another direction is from output back to input. So you cannot just do minus here. The direction are not the same.
yes.
So if you remember the formula to close the loop, G1, G2, 1 plus, right? G1 and G2,
G.
right?
Yes.
This is the formula to close the loop. And how to let Matlab do this for you? You think the code is a negative feedback? Do you think it's too long?
Yes, too long.
So
So
yes, it does have feedback, the vocabulary, but not the way you just say it. It's what?
negative feedback.
First, feedback. Of course, right?
Mhm.
Oh, okay. And what should be right in here?
G1 minus G2.
First, you should write the transfer function and the forward path. What is the transfer function in forward path?
Is G
Forward means from in to out.
out. So out what?
Just 12, okay?
Yeah.
G1 is the transfer function listed in the forward path. And the next you should write is the transfer function listed in feedback path is y. And then the last one you need to write here. It means a sign. A sign. If this is y, means what? It's a positive feedback. But if you write -1 here, it means what? Negative feedback. And sometimes you can even take it off. So what is the meaning for just G1, G2 feedback? No sign here. No. Negative. Because most of the feedback system, mostly of the feedback system are negative. So if you left nothing here, it is negative. So we see C equals what? Feedback G1, G2, and -1. Same with what? No same? Not same, okay. It's what? It's G1, G2 over 1 plus G1, G2. If you write it by your hands and compare these two results, it should be the same. Okay, if we left nothing here, we just write G1, G2 to see if it is negative, okay?
Yeah.
These two?
Same.
Same, so it's okay to say -1 here. -1 or no -1 or no 1. The same. But if you write, let's write, let's run 1 here. Things are different. It means positive feedback. It's right now? Not the same, right?
Not the same.
So this you should write a sign here. -1 or +1. -1 means negative. +1 means positive. There's nothing here means negative. Clear?
Actually, G1, is it G1 dot G2 or G1 comma G2?
Comma. So we learn how to simplify a diagram, block diagram I had. But if you do in Matlab, get much easier, right?
Yeah.
So I think Matlab is very helpful.
Yes.
So maybe I will write down all the codes we just talked about. First, okay, this is as long as you know the numerator and denominator matrix for the system. You just use TF code to get a transfer function. And but if the system is in form of zeros, poles, and again, then use this code.
Yes.
And you can change from one type to another by one. You can get numerator and denominators by from VP form to TF form. Z, P, and K. And how to get ZPK, zeros, poles, and again from TF to Y.
ZPK.
And what you know is what? Numerator and
Then
denominator.
And if here are this one and these two are known, we want to do in series, then how about parallel? Just have this one and this two. And then last one, feedback. Yeah, right here. And here is something you should know about C3, C6, and sign. Sign is +1 or -1, okay? Means positive or negative feedback. And 6G means the transfer function listed in the forward path. C6 means the transfer function listed in the feedback path. Okay, here are the codes you should be familiar with, and maybe we finished the class in the classroom. Of course, in classroom we have 2 weeks class in lab.
When the last class?
Fifth
15. Okay.
January. Is it right? Did I get wrong of the code? Maybe. Let's see. Let's check. Yes. Including today's class, there are 2 more classes in this room.
So next week lab.
And we have 2 weeks class in lab.
But next week is the last class.
2 weeks.
Still have 2 weeks class in classroom here. And by finish that, the following 2 class are.
But Lashe, I had vacation pushed for.
I didn't get the information about that. Maybe the administration will talk to me if they, I don't know. I don't get this message, so
No
just
problem.
just do as we just plan, okay? Okay. How to clean up the command window? But remember, CLC is just cleaning up the window, but the parameters and the variables and the results you just got are still stored in workspace. Then how to erase all the knowledge in workspace? Clear. Oh, it's so easy because you were speak English. So easy, right?
Yeah.
But when I started to learn Matlab, maybe the version of that Matlab, it's 2008. This version. And at that time, all the menus and the buttons are all in English. So I just learn English and learn math at the same time, And nowadays, from version 2630, the menu is translated into Chinese. We have Chinese version. So nowadays, Chinese students, it's easy to use Matlab, but only menus, the code is still in English. No Chinese code. Okay, here are some knowledge about how to use command windows and some codes to write in the transfer function into Matlab and do some simplified connection to get the final transfer function. And one more software maybe in Matlab, you should be familiar with it, Simulink here. Maybe we first should add a new Simulink model here. You know, the Matlab, sorry to install a Matlab needs space like maybe more than 30 GB. So it's a very, very large size.
This version.
This version is, let's see. Yeah, 2013. And if this year's version, maybe it's the space unit is getting bigger and bigger, maybe
This
what?
is 34. This one is 15.6.
Okay, let's see. Okay, by add a new simulation model here. You first get a what? A blank space here.
Yes.
And you can draw the block diagram here.
Then it's serious.
All right, I think, yeah, by this, you just plot the block diagram here and you just connecting all the parameter variables you need, and it can run the simulation. It gets what kind of input and it shows up the results. So how to do this? Maybe we need first to see a.
Actually, I think that I'm not your computer. Because I think your computer will run.
Battery life. I'm taking off your computer battery.
Which way?
The battery life
Matrix
is low.
Battery. Power.
power?
It's low. We run.
Yeah.
Oh, you mean the battery?
Don't worry.
Don't worry, I think it's. It just shows up the warning, or maybe I will plug in the. Okay. Okay, still left like 1 hour. It says I can still use 1 hour, so it's okay. Okay, here. See, we have a.
Yes.
Okay, if we have a system like this, the forward pass, how many transfer functions are listed? Just two, one and there is what? Zeros, right?
Yes.
What is the feedback transfer function? Maybe it's one, right? And now you get an input signal here. You will have what? An output, right? And how many types of input signals we've learned? Just say it out. Which one is what? Step, right?
Yeah.
And what? RAM? And what?
Unit step.
Unit step is also step signal. Step signal, RAM signal, and what signal?
Loop.
Actually, sine wave or cosine wave can also be used as a input signal, right? Okay, there's so many. What we're familiar with is step, RAM, okay. And see here. Then how to use Simulink to do simulations of this system. First, you should draw the block diagram into the blank. Then how to? Let's see here. Here's button here showing library browser. And you click, and it shows that all the elements and all the transfer function maybe you need here. And you see here like common username blocks and continue blocks and discontinuous, what we have in the one here, discrete and logical and math operations and all things. Scope here or display here. And the sources are the input sources we can use, like clock, maybe it's a clock signal, and it's a constant signal. And here we will have ramp rate, pulse rate, remember? And here it's step and the sign, and so many types of signals we can use as input. And first, we need to draw the block diagram for the system, and then decide which input we need to use. Then this and this are, you see the S here. S means Laplace transform, right? Laplace transform the system. If the system is in Laplace transform, then it is continuous system. So you should find the blocks you need in this menu. Continuous here. And then you see here, it's a transfer function. See the block? Transfer function block. See? And what you need to do is, okay, here. Sorry. Drag it into the blank. And maybe we can. To see if we can zoom it. It's too small. Then zoom. Okay, it shows a transfer function here, right? But actually what it's showing here is the numerator is just a constant 1 and the denominator is s plus 1. It's not the transfer function. It's just the transfer function we need, the first one, right? Then how to draw the second one? First, duplicate it. So you have two transfer functions here. And then click it, and it shows up a transfer function, a parameters block, and then you can set up all the parameters you need. And here, it's just the code we're familiar with. It just separated into some blanks we need to fill in. The first one is numerator coefficients. So what is the numerator coefficients for a second transfer function? You write what? Instead of 1, we need to write 6 here, right? So how about the denominator coefficients? Where is here? Denominator of the second transfer function. What is the coefficient? 1, 2, 1, right? So apply it. And here you can see here. Is this the transfer function we need?
Yes.
So we get two transfer functions in the forward pass.
Let's see how it became s squared. What's the
And then another element or another block we need here is what? Right? Yeah. We need a summing point. So actually, summing point, what's the function of summing point? Do the math for us. Minus. So which menu you should refer to?
math operations?
Yeah, math operations here. And see, we have add here. First, we drag in the add block into here. And maybe next we see a sum here. Drag in. Though one is in the shapes are different, but the functions are the same. You can choose whatever you like, okay? Here, maybe I use the circle one here. And connect them. Just drag from one to another and a line word shows up.
Now, shit, example in this document function, if we put like four numbers in the denominator, Matlab automatically will put that on.
You mean the denominator has,
Example, four numbers.
it's just the same. You can show here. If it is maybe four numbers here, you apply it and just show the same. It's just denominator coefficient matrix according to the decreasing order of S. Clear? Here we just. And then what's the next connection? First, we have two transfer functions here, and then we have some point already. And if you want to see the output, you need to use one type of thing, maybe scope, maybe display.
Yeah.
Right? If you don't use one of that things, how can you read the output? And because we input a signal here, we should read out output. We should by using instruments if in real text, in real experience. So scope, display, both showing up the result. One is by curve. If you use scope showing a curve, right?
Yes, sir.
And if you use display showing the digitals, the numbers. So here, because we want to see by, can you still remember the last chapter with time response? What we can tell from the time response, like the different time that like submit, peak point, overshoot, right? How to read that? You need a curve, right? Then how to get curve? What elements, what instrument, what block we should do? Scope, right? So here, since we drag the scope here to the blank, and then the output should directly connect to the scope. And the scope will show up the output curve, right? But don't forget one more thing as well, feedback. Then how to connect the feedback line. First, you choose the line here and then click the red button and drag a new line here and directly to the here. Right? And it shows k equals 1 here. It just equal to a straight line. Okay?
Example, if
3, okay. Then you need another, maybe I drag it. No need to use transfer function. I think, see again here? Again, just maybe you should. It means what? From this direction to the out direction, constant, the gain here is 1. If the gain is not 1, then you can click it and turns up open the parameter block, and you can change the gain number here, maybe 3. Okay, here is 1 still, right? And now we have feedback, but what we need is a negative feedback. And here says plus plus, it's positive feedback. How to change it? Click it, and we can change the parameter block. Here shows plus plus, right? And you can change into plus minus, and we see what change we'll like. See here, we get a negative, right? Okay, just delete it. So most of the blocks we need is already here. And one more is what signal, input signal you choose. And here, maybe first we can test for the zoom in. 这是看什么 Okay, we need a source, right? Let's try step here. Connect step into the input signal. So we have an input signal, it's a step signal, and we will have a output showing in a way of curve in scope, right? And by reading the scope curve, we can learn like overshoot, or the peak time, or the settling time, or the time index we need, right? Okay, but here, just open the parameter of the step block. We know here are some parameters maybe we need to adjust. The first step time means when does step happen. We learn unit step, and if we talk about the unit step, right? It means the step happens when 0, right? When time is bigger than 0, it just happens to step to the value, a unity value 1. So here, if we want to change the parameters, just like what we learned, the step time here should be 1 or 0.
As you said, T is 1 when it's bigger than 0.
Yeah. The signal of the step is 1 when t is over 0. And when t is smaller than 0, or maybe we can.
But where's
Okay, here.
Where's T? Where's T? How do you know if T is greater than 0 or less than 0?
Okay, let's have here a step time here. Maybe we change it to a bigger number, maybe 20, okay? Initial value means if the step doesn't happen, what was the initial value here? Maybe we set it to 0. And the final value is 1, means the whole step value is 1. So the step is what? A unit step. But what does the step happen? When does the step happen?
After
20, the unit is seconds, 20 seconds. At time, when time is 20 seconds, this step happens. So from 0 to 20 seconds, no step. It just happened after 20 seconds. So here, if we say like this, sample time, you can just leave it 0. It's okay.
What does it mean? Like if they use like
Sample time is what? Because we only learn continuous system, but we know if a system is functioning in computer, then it is not continuous system. It's what? Discrete, discontinuous. The computer system just record the values what by each of sample time interval. Remember, so a continuous system by if you do the how to say that, do the sampling in each interval, time interval. So the whole, see here, continuous system. Let's see, the continuous system is a curve, right? And but if you are in computer system becomes discontinuous. It's what? Maybe it's just will do the sampling by each interval, and this is per interval, and this interval called sample time. And how can a continuous system become discrete? System will take the value at each interval. Let's see here and here. We just have the value here, and by next interval, we read the value here, and next step, have several values at each time interval, and the system will connect them not by a curve, but by what? Oblique line. So it will be like straight line, not curve. So this is what? Continuous system. This is what? Discontinuous or discrete. So sample time is the time interval to take the value of the curve from straight line. And here, because we only talk about what? Continuous system. So sample time is not the parameter we can just leave it 0. So it's okay. Okay, showing here, it says 10. What does 10 here mean? It means the simulation time is 10 seconds. It's 10 seconds. Yeah, but we set this happens when 20 seconds. So what you're showing here, just the 10 seconds curve. So it doesn't enough, the time is not enough. So you should enlarge the simulation time here to make the scope showing the curve, the whole curve. So maybe we can change it. I think it should be bigger than 20. So maybe 50 to see, and then you can save it first. Maybe just TT. Okay. Okay, we have a model here, and then click the run button. Okay, and then click the scope. You see the curve is showing up. When does the step happen? 20, right? Because we set the step time to 20. It means from 10 to 20, no step. The signal remains 0. And when time is bigger than 20 seconds, bigger than the step time you just set, it happens the step. The signal is changed from here. So the output will change after 20 seconds. See here? And you can try to change step time. Maybe it happens just from 0. It just step in the very beginning. So let's see what will the output curve be like. The out curve response immediately on the simulation start point. So step time is the time you set when does the step happen. Remember? Yeah. Clear? And here we can what? Final value. If it is not a unit step, you can change it to whatever value. Maybe now this, imagine this is maybe a model system, and maybe we need to control the frequency of the model working, and maybe the value is not 1 to maybe 2000 the frequency. Maybe let's set like maybe 500 to see what we'll like. And by run it, and by this, this is the response of the output by input a signal of 500 step. 500, and you can.
Why is that actually like 700?
Overshoot. Of course, overshoot. It does have overshoot and has several overshoot, and the biggest one happened. Remember? So this is an oscillation system. Though it has overshoot first, and then as time tends infinity, we can imagine it will be stable at maybe 500 or maybe bigger than 500 or less than, but the currency is not that precise. So maybe we can just change the simulation time to longer time here. Maybe 20 seconds, 200 seconds to see. showing just see as time turns infinity, what the whole system is what getting stable has a limitation, right? And the final value is less than 500. So the currency is not that okay. Because we want the target is 500, but finally it has a maybe still less than 50 arrow value.
What can we do to system to keep it 500?
Then you should change the parameters. And you can change the parameters to just recur to the requirements you need, system requirements. See, that is why we need to control the system. You control the system. What is the control? If in the block diagram, it means you need to change the parameters to make the curve meets the requirements you need. System, okay? You mean a control system, right? Okay, let's see here. Maybe if you need a control system, we can add again here. By first to see maybe 500 here, and it's 20. Okay, let's see. If you change the again maybe to like 2 to see what will change. You see, if the gain is changed to 2, then the system is what? It's unstable. See here, it's unstable. As time tends to infinity, the value of the output gets bigger and bigger.
Yeah.
So it's unstable. So 2 is not okay. It means the parameter we just set for the gain 2 is not okay. So the gain here should be less than 2, right?
Yeah.
Let's try maybe 1.5. Still unstable. So this is not okay. Then you should just decrease the value, maybe 0.5 to see if see here 0.5. It just overshoots, but the value is what?
Yes.
Lower than 500. So here is what you need to control system. You need to adjust the parameter of the controller. And here the gain block is a controller. The it is controller. Just again, right? So it just from this simulation we can read the message. If you want to control a system like this, just use one gain as controller is not enough. It can adjust the overshoot, but it cannot ensure the recurrence. So maybe more complicated controller you need to choose. This is just because what we want a system has is the system's response we need is more what? Faster. We want a system to respond to a input faster. And then what? Stable. And then what? Occurrence. These 3 are the targets we want to control system. But actually, each of the targets will what? Has influence of another. That is to say, you cannot control a system the fast and the current and the stable at the same time. The 3 targets will affect each. So you can just ensure maybe 1 or 2 targets, maybe faster, maybe stable, but no occurrence, or maybe occurrence or stable, but maybe not that fast. So it depends on the system requirements. If it's a temperature adjusting system, we know if you want to keep a room temperature by air conditioning from 10 to maybe the temperature here is 10, and you want to adjust to 25, then the time you need will be what?
10 to 25.
10
25.
Yes.
So it will take longer time, right? You can just look like. Okay, now we have the input of signal. This is temperature. Maybe the temperature we need now is 25, right? But actually now temperature is what? 10. So a system will what response to the target will have a curve. It will increase from 10 to 25, right? So it will like maybe this, right? And keep around 25. And the time you need from 10 rise to 25 will what? Will be that within seconds? No, it will take like maybe 10 minutes, 20 minutes. So air conditioning system, the fast target is not the first target you need to consider. Accuracy, maybe because we want it keeps around 25 and the occurrence can maybe just maybe from minus 0.5 or plus, right?
Yeah.
This is the currency, right? But we cannot ensure the speed for the system's response because air conditioning, temperature, or digestion system, it's a low response system. But if it is a motor speed, if you want to control a speed of a motor, the response speed is very fast. So fast at that time is what we need to take into consideration. So different system, different instruments, use the target choose for control. It's different. Clear? Okay, we can have rest here. You think Matlab is interesting?
Very.
But why do you look so sleepy?
It's so interesting.
Because sometimes
we don't sleep like that.
sometimes you don't have maybe from the very beginning of your research, you have no funds or you have no instruments to review experiments. Then you can just by doing simulation to see if your plan, your scheme is working, it's okay. That acts and then you can do the real experiment later. So simulation is
Actually, we want to have a real experiment of it.
We are waiting for that. Yeah.
or how many you want.
This one is that one 10 minutes. This one.
Half an hour?
Yes. Okay.
Okay, half an hour. So you have rest, I have rest.
Thanks for your comprehension.
So yesterday there was a meeting, the Lanchang Special Fund Corporation. Yeah, you attend, right?
You attended?
That is when he gave me.
You were in class.
You were in class.
Yeah, we had experiments.
Also Chen was the translator for that because Laos department is participating in that meeting. So she was the translator.
Who is one?
I don't know one.
You understand?
No.
I saw you talked to him yesterday. You don't know him?
I know him.
We all know him.
We don't know.
We all know him.
He speaks very good Mandarin.
Yeah.
Right? And by the way, I can tell it.
Bro, I went there after class.
You were the translator.
After
You were the translator.
Oh, yes, maybe next time, maybe your country will become the meeting with us, then you can be the translator, to translate local language to Mandarin.
Well, that's it.
Yeah, like
Or maybe
I think for me, my country, fine.
Yeah, I think your English is good, but you know, the English in Laos and Thailand and Cambodian.
They look like Chinese.
Yeah, I can't even tell what's Chinese language in there.
The first day he told me, ask him, he's shooting arrow. No. Then he started laughing, and I was like,
Funny, huh?
he looks like a Chinese. His picture and everything, you know, like everything, even the way he dresses, everything. He looks like
Really period.
yeah. Yes.
And another one. What is the biggest fund you raised?
National fund?
Yeah.
National fund for the younger scientists.
How
Not that much, you know, the national fund just like, let me count. Maybe, okay. Do you want to know the number?
Actually, what's the funding for?
For a network control system.
Oh. So the government gives the students money to do research on network.
20,000. 200,000.
Yeah, no.
You
人民币。
maybe $20,000. No, 25.
You know, national fund, not, if you do the project with corporations, with companies, the fund will be, yeah, higher. National fund or the provincial fund.
So actually, the national fund is for students.
That's so hard. I don't know.
Students.
To researchers.
No, researchers. Those in masters.
Come here.
Or those who are done with masters.
I'm in charge of the fund, and I can give salary for the students who have to do the research.
Oh.
Sorry.
I see that. So actually, the master's students who don't do research. The master's.
Just
No, you have to pay
master's.
them.
So you have to pay
them. Which one? Masters or bachelor?
You mean
The students.
students?
Is it master's students or
Master.
Masters.
Master.
Just
Just
Yeah.
masters.
Oh.
Seldom.
Actually, when I start masters, my school will
That moment will be 400,000, I guess. The economy increase. The
Actually,
economy increase.
I think control system.
It's fine. It's interesting.
It's interesting, but I think it's not hands-on.
It's all
Is it
about money.
hands-on?
I know you trick.
Time is going.
Actually, is it hands-on?
What?
This course, the master's course for this, is it hands-on?
Hands-on for?
Yeah, like as in, like you get to do the practicals yourself, like each hand. As in you the stuff, or it's more or less like controlling this system, controlling the laptop.
No, I have
Is it
Most of them.
virtual or real?
real instruments, real control.
Most of them, like, you use computer and.
Yeah. This is just a series you need to learn first, and then you apply this theory to the real instruments, to real control.
So actually, this major, is it lucrative?
Research is okay, but I don't know if that you will get high paid in company by majoring.
Sometimes it depends where you will work or where
Yeah,
you
it
with the
Then-
country.
And also it depends on the country.
What is for rent lab or
What?
you need to rent lab?
To what?
Rent
Rent? Oh, you mean the instrument?
instrument and lab.
Yeah, but
You need to rent it or
they
you
real like you
like
wanna feel like you're getting the real life. Like
Yeah,
the
master.
Actually-
You learn this. Oh, you be careful.
Actually, the object you chose for control can be big or small, or can be expensive or cheap. A small car model can be controlled also, or very factory instruments, very big one can be controlled too. So depending on your research field. So what I do now is network control system. That is to control system over internet. So maybe the controlling part is in China, and maybe the object I need to control is over there in England. So I can do control by internet due to distant control, not local control. So this is what I am researching in right now.
So actually, after has there been any solid breakthroughs? Have you had any solid breakthroughs?
I already applied some theory in the control, and I am successful in controlling the tank level control that in England and control from China.
Wow, actually, when you finish, you can share us your knowledge for real.
Maybe.
So actually, if Suhan is in Bangladesh, I was doing it.
For real.
Huawei is more about maybe phones chips, electric engineering maybe. Yeah, it does has control things, but not that much maybe. It's more about computer science, I think, and chip science, chips.
Yeah, semiconductor.
Yeah.
But actually, it's a little confusing to know what you want. Because there are a lot of things in mechanics. It's hard to select which one do I want to do. So you try to consider which one do I love, then you start to ask yourself, what I love, is it lucrative?
Then I think interest comes first. Interest comes
When you
first.
want.
Yeah, interest.
That's the problem I have. Like, I'm interested in
And
meaning.
don't worry, you can just by learning and at the time find what you are really fond of.
Actually, that's I like everything. So I don't know what to.
You are confused.
But sometimes the ways come just opposite. For me, I chose the major like automation, chose major control. I don't know. At that time, I just ended at 3 years school, and I don't know what is really that about. I just chose such as okay, I can truly okay, so just this time, not the very beginning, I find it very interesting, or I love it actually. It's just my chance. And as time as I learn it, you can do. I think it's okay.
Actually, is it
Of course,
very difficult?
to the level like to the doctors, master students, to the now PhD degree, it's a much.
Actually, in the master's level, if your bachelor level is not so, it's a very big problem. You start the master, the bachelor level is weak.
I don't know your process for applying schools for you guys, but for us, for Chinese students to apply the degree abroad, and the scores you get campus is very important.
Yeah. I know. I mean, like, let's say here, studying here in school, bachelor, degree.
Yeah.
If your degree, like, knowledge is not so strong, you go to do masters in that field. Because sometimes, for instance, maybe I want to do maybe exam control systems, but maybe I don't get a good teacher for, like, you are good, of course, but imagine this is an exam. Imagine you don't get a good teacher for that course. Now you are scared. If I go do masters in this course, maybe I think maybe my knowledge here is not enough. Is it a very big problem?
I think that is their big thing.
The masters you can cover up.
Yeah, I think because what you learn in which order, just basic. So I think it. I don't know if you have the interest in that for you to apply master degree. You just prepare the materials and you have exams to get qualified for that.
We are qualified based on our results here. So if your results here are bad, you can't do masters in a course you like.
Oh.
So maybe if you want to do masters, maybe big data, they require very high marks. I checked the score for Chima, you have to have 85 and above.
Oh,
in your
average.
bachelor. Yeah. to have only 85 and above. And English test, IT.
Oh, it's a different because Chinese students, if they want to apply the master degree in China, then sports is in one hand, and another hand, they should pass an exam
Oh.
to get qualified for applying to that school before they require special test. So this thing combines two hands. If you are not getting nice scores, but you pass the exam, they give to you at the high school, then maybe they will think of you to enroll you into their education. So they have two chances. One is
We have just
one, yeah.
if you don't do well here, so
Now how about
you take the course. Yeah, if that's how I said it.
but now you're right, and maybe the scores for $9 not that nice,
But
and then you want to make your resume beautiful, and I suggest you to participate in like competitions that allow foreigner students to, and you have the experience to join in the competitions, maybe finally.
but she mean, that's not my problem. As like the problem for me is not the marks, because my marks are okay. Yeah, they are okay to apply. But the problem is sometimes I get scared of what I'm going to face. As like when I hear something like this, I begin to imagine to me, oh my god, this is this. So that I get it. So sometimes I get a little nervous. Maybe I know some stuff, but I feel like maybe not enough to study.
And for you and both for Chinese students, what you only learn about knowledge of theory. You still they have the chance to apply the theory, the knowledge you learn to the real things. And theoretically how that will work. You will see how really it works or how to control real things. So that is the thing, that is the problem in both ways. Not only you, but me and my Chinese students also.
Really?
Of course. But for master students, things are changed because they can enter in the lab, so they can do some experiments and real experiments, so they can connect the theory and knowledge in textbook and the knowledge and the real problems together. So I don't think it's a problem for you for the foreign students learning here, but also it's a general problem for those cultures. You see?
Because it's the same in my country. We just study, we memorize the book.
And sometimes I even met my baby and master students, just a new one who come in here. And they pass the test all the time and very high school. But they know little things about nature. They only do it. Actually, they not have the strong ability to research. Yeah, they only know how to get high schools in Texas. You see?
Then it's a basic problem because here it's
Yeah.
the same. My country is the same. And we complain always.
That's why I choose to learn abroad. Because when I did my bachelor's education, I found the problem. I just asked you, a new idea, a new system, frontier things. I don't know, and I don't know the real what is the real word. This is function, and I will have the chance during the lab, but I'm just a bachelor student. So maybe I need to go abroad to see if I can get chance into the very good lab and the foreign schools.
But is it different over there? It's almost the same because they're master's students.
Yeah, but it's master, so things are okay.
Because I chose to come here because of the same.
Yeah.
Yeah, even me.
I was in mechanical.
So
student,
you
but I
should
chose
try
to-
harder to be welding and to have better skill. Maybe.
Yeah, sure.
And I think mechanical engineering, I think it's a good try.
But now she's too broad. That's the problem. Like
Yeah, you need to narrow down. You need
Yes.
to narrow down the field you're
To
interested.
narrow is the problem. Because me, I find myself I like to design, like the machine design.
How to do narrow down? You need to
know more things about it and then have to learn. You just know the little things about mechanics. The narrow space is very small, you know lots of about it, and then you can choose. I think it's okay for you to like read some publications or papers published and you see what's frontier problems or the hot topic in this field. Fine. And what do you want to learn?
Creation of stuff, like producing stuff, not production comes in different ways, not as in producing stuff, but like machine engines, stuff. And on the other hand, I like softwares and programs.
And I think you have the like just internship. Maybe not the internship is not really allow you to get started by hand, but allow you to see things in real factory, real company. Maybe the college will.
Yeah. I've seen this one.
Yeah. And last semester, I was instructor for them to get into the mechanical factory to see how things really function. That is a good chance. Also for Chinese students, they can too.
Actually, how do you combine these masters? You have to take only one, like you have to go for only one, like field, or you can combine.
Oh no. When I majored in bachelor, it's automation, right? And then when I went to America, my major is mechanical and aerospace engineer. The field is changed. And when I'm back to China for PhD, the field changed to network control. So, but it's in a big area. It's just it's all in the area of automation and mechanics, but the directions are not the same. So what I find the real direction I want to during my PhD education.
So we do both. We do mechanical and our courses combined. So and me, I was thinking in masters maybe I could combine two. Can I combine two masters?
Of course. So this is the whole process how mechanical engineering works. First, you design the structure of a mechanical design, and then you design the controlling parts. This should combine together, and then you will be a good engineer.
So in masters, what should I do? I should do mechanical and control.
If you learn well about design in bachelor, then you can choose control in master.
I can add it to design.
Yeah.
Because we are doing design too. Because it's fire.
Because fire.
Yeah.
The way you are saying, right? What?
No. The thing is, my question is not about wanting to know what I want. I want to know if I can. I know what I want, but you're making me design and information. I want to know if I can combine both of them. The masters.
No,
You will actually.
You have to know if that's the one you know. If there is like you can do that way. You can find a university that is the reason my brother now they went that way. I mean, they did this very fast. Now he's going for that. And my thing is that is the same. No, I don't know, but the problem just like is the years. But the years and
They couldn't have depends on what you choose.
but there's like a minimum. I was talking about especially most of the university. No, for she's applying.
Listen. Because of the school she applied.
No,
I get the same. She studied. Depends on
this
how
one
you
what she
combine.
said.
Depends on how you combine.
Like they say,
There's a course for 2 years.
they say 2 years is hard. You can find it like a course, it's not 2 years.
I mean, my brother told me if I get sugar, we need to give 3 years for free. You know why? Because if you go to a place that you give it today, you still do the same chunk of work. Yes. The quantity of work is the same. You understand? So if the quantity of work, let's say you have 1,000 quantity of work, they give you 3 years to do it. You can take your time. But if you are given 2 years, you rush you through the process. Yeah.
Feeling old.
I know.
Finish.
That's the thing. If you start thinking like this, you rush things.
Which rush one?
Don't rush things now.
I'm not rushing. I'm not rushing. Already.
That's it. Because no.
And for me, I guess I'm 3 hours. French. Because French, yeah, French. When you work, when you have 1 year, out, even when you go now, I don't know how there is someone my girlfriend. No, you can study in English.
France.
Yeah. When the corner rush came, I bought the one I said there.
Studying English.
Yes.
France. Wow. That of this language is you tell you that you should just get something.
When my brother traveled, he said, I'm
just giving it. You don't know.
and he said, in 1 year, when you go there, they will make sure you have to give my brother, my sister, one of my sister-in-law, and now she stayed 1 year. That's you see another good country, which time is this one to work? Allow. No. You see these people, they don't like to work. This time, bro, I have one guy just had high school, they left. Bro, the guy is working there. These guys are lazy.
And they have another problem.
And they pay.
The biggest problem is when you keep these guys from they are wanted. Then they really like this guy. Then he's one.
In my they are still in Luna. They are also
One is
some
so
of them they
good.
they're asking for a lot of money.
What about nowadays?
So we see
How
like
much
bro, one day.
We are
You have
That is boss. You know what we said? That's the
or me also if I got I will just give that person my email. A lot of money. And then the plane is so expensive. It's not like you are even close to here. It's so expensive. I have to pay two planes.
So you were just really yeah. Then people 2 days.
like flying 2 days?
Yes,
Wow.
yes.
That's beautiful. For us,
This guy,
just
you also sit there.
I can't do nothing.
Yeah.
2 days we are flying.
She said 10 minutes.
Good thing until now, I'll tell you where you skin thank you.
She just left right now. No, for real.
Stop looking at me. Stop.
Which book are you? I'm looking at you.
Deixa.
Leave. The way I'm looking like someone is going to meet
Hey,
Jesus.
off that mic.
With
My
white
dad say I'm
wine.
talking too much. They are hearing me. Off that mic.
Who?
My dad, she say I'm talking too much.
Oh, this mic.
Off the mic. Off the mic. We are breaking that.
I was like someone is going to the sky. White wine.
This guy.
You are already evil.
I gotta go.
You are already evil.
Hey, do you think you are not evil because you are wearing white?
You don't know why it means peace. Go, I want to eat.
Get out of here.
That's good. Let me get the key of my office. She just left right now.
Go right now. Check what I mean. Four, three.
What about others? Can we continue?
First one finished.
What? Yes, already half an hour passed. Nice song. Are they coming? When can we get started? Just four of us. Okay. Here we have a closed loop transfer function for this. Then compare with, you remember the general form for a second order system? Remember S squared plus 2 beta omega n s plus 1. This is what? General form for a second order system. So compare these two. And get for this system, what is the omega n squared? 16. That's squared, I mean. 16. So omega n squared. Alright. Then we have 2 zeta omega n equals to what? 5.6, right? Since we have this and we have this, then we can have zeta equals to 0.2. Right? Yes. So this is what we, by comparing the general form with the form we have, and we can have the omega n and the zeta for the GF. Then can Matlab help us to do math? omega n here n, the omega n here, so omega n square n, and 1.6 equals 2 zeta omega n. 2 zeta omega n 1.6 and omega n is 4. Then we can have zeta equals to, right? We do it by hand, right? By math. Then there is actually a code in Matlab to do math process. So how to? First, of course, we need to type in the transfer function into Matlab, right? Then how to? First, we need to type in the numerator coefficient matrix, right? It's what? Numerator coefficient is what? 16, right? Just 16, no S. So how about denominator matrix?
1.6.
Here has 1, and 1.6 and 6. And then how to get the transfer function? You get this equals TF, remember?
Yes,
Here, now,
TN.
let's see if it works, okay? We type n now equals 16, right? And then equals to 1.6, and 16. And the whole system transfer function equals TF now and then. And the transfer function showing here, the simple one, right? Yeah. Then
Yes.
how to get omega n and zeta by code, not by n. From this we can read omega n squared is 16, omega n squared. And by this we can read the zeta is 0.2. Then there is actually a code to help us get omega n and zeta. What is the code? Let's find the code here. No, not here. Oh, okay, here. Here's a code called and this host, if you want to get omega n zeta equals them, call them to what? Let's try. Okay, if we use the code let omega n and zeta equals to n. Let's see what the result will show here. See here, by use them code, we get omega n has 2 values. 4, y is 2 values for square. So it's 4 times 4a. So because by computer doing the math, it got 2 results for omega n. So it also gets 2 results for zeta, but the same rank. So actually it's 1 value. So this code helps you automatically get omega n and zeta for a second order system. Easy? And we know by draw the block diagram in Simulink, we can use scope to read the curve of the output. And actually, we can use code in command windows to get the curve too. Okay, still, this system is the closed loop transfer function for system. Then if we give it the input signal a step unit input, what will be the output? Let's see. Okay, here. We have a system, right? And then how to get output curve by inputting a step unit, a unit step. Here we need to first, remember in simulation, we need to type in the simulation time. Remember, first you should settle the time. And here, the same, you should settle the time for what will be the loss for x-axis for the time to showing up. So here, you define a parameter t from 0 seconds to when? Maybe like we show you 50 seconds. And here we need another value here means interval time. That is to say the computer, remember the interval time? I think by which interval you read the value for each point. So here, if I set 0.1 here, let's see what will be like for t parameter. Showing here, right?
老师 Can you hear me, 老师
So we have several time points. One is first is from 0. Another is what? 0.1. You set the interval. And then it's what? 0.2.
Lastly, someone need to talk. Please.
What will be the end point?
Response.
50. So this is what you set for the time.
老师 Can you
Okay,
mute
now
all
we
the
have a
students?
system. We have time. How to get the step response by inserting a unit step. The code is so easy. Just step. Just step. Okay, step. And first, you write down here at the system's name. Sys, right? And then the time you just define. See here? And by running the code, okay, busy. My computer is still working. Showing here, right? This is what? This is what? A step response curve. Just same as simulation, right? So if you want to get a response curve, you can use code and you can use block diagram. Both can do the simulation to get a curve. And then see this curve. What is the hit time? Okay, maybe we maybe T50 is too long. Maybe we just decrease the time we need to maybe 20 to see the clear.
Those who are asking new toilet, someone opens my phone.
老师 Can you hear me?
Me or others? Mute all the other speakers, right? Okay.
老师
Oh, I didn't share the screen. Okay then. And what? And mute. This one?
Yeah,
This right?
yeah.
It's mute already?
I guess not.
No. What? To see. Okay now. Okay now. Okay. Okay, this is the curve within 20 seconds here. And what is the peak time?
1.5.
Maybe. not that interesting. And what is the overshoot? I mean, here, right?
Yeah.
Here, right? So you can read yourself. Actually, Matlab can read for you for those index you need. How to then? Let's see here. Let's see characteristic. See here, peak response. If you choose this, and then here happens a point here, point out, and it says what? The system name is sys. You just define, right? The peak amplitude is 1.53, and overshoot is 52.7%. And at which time? What time? 0.8, not 1.5. So you get wrong, okay? The computer reads for you. So it's actually this time is what time? 0.8 is what time? Peak time. Because when is the overshoot happen? It's the time of peak time, right? So this whole the parameters you need, computer just reads for you. And what about others? Settling time. Remember, if you choose another point comes out, tells you the settling time is 4.9 seconds. And how about the rise time? Remember, what is rise time? From 10% to 90% of the final value. The rise time, right? And it's showing here the rise time is what? Can you use? Okay. It's not. It's what? 0.306 seconds, right? And how about steady state? Steady state means the whole system response entering the relative stable situation. So maybe it happens when time tends infinity. So the final value shown here is what? So this whole system responds to a unit step. The output curve is showing here. And the Matlab can read all the parameters you need for you. So no need to read the figure, and it gets more accurate results for you.
But see, that's the case then. Why the traditional method? You can just do the math.
But you need to know what is the definition for each parameter. So first you need to know what is peak time, what is overshoot. If you don't know, it's showing up, you still don't know. You know? You see, theory, knowledge is basic. And Matlab or other software are tools. Clear? Okay, maybe we can start today's. Still left like some time to start chapter 7.
Okay. I forgot when you were in Matlab, which place that you want to plot the blocks. I forgot.
Simulink. Yeah, Simulink. You can try to find the button showing Simulink. Maybe, okay, let's open Matlab again to see. If you want to use Simulink, then here, opens the library. Here, wait. Too slow. You know, sometimes if the whole simulation block diagram is too complicated. Maybe it takes not hours to get the curve.
Hours.
Yeah, if the block diagram is very complex, maybe several instruments connected with each other. This is the easiest. A single feedback. Maybe you have several feedback and lots of loops.
Yeah.
And then you run that program. So it takes hours to show you the curve.
So actually, to take a human being maybe
Yeah, human, maybe.
actually hand calculation hour.
1 month.
No. Okay, here it's showing like library browser. It's showing the blocks you need. And then by open a new model, it will showing up the blank space, and you can drag the block you need to the blank space and running it and settle the time. Okay. I can't close it. Why? Okay, whatever. Why my computer is so slow?
Actually, the heat.
Yeah, maybe the heat or the heat.
Oh. Really? Wait, why? I cannot see.
So, push off for some time. Actually, are you okay? Maybe we can off it for some time.
Okay, I don't think it is working right now. You can turn it off. Maybe. Okay. Am I sharing the screen?
No, please.
No?
Yes. Shit.
You see if I'm sharing the screen. Oh yeah,
Oh, share.
share. Continue chapter 7 a little bit. So last chapter we talk about response in what domain?
Response time.
Yes. So this chapter is about frequency response analysis. So we talk about response in frequency domain. So here is syllabus for digital chapter. First concept, then graphical descriptions, Nyquist diagram and bold diagram. Two scientists name. We invent the diagram. And third, the open loop bold diagram of control system, and then minimum phase system, Nyquist stability criteria. So concept here, the frequency response is defined as the steady state response of a system to an harmonic signal image. What we just use is just a step, right? Straight line. But here, if you talk about frequency response, then what is the input signal? Harmonic signal. Actually, harmonic signal is a sine wave signal. And its form is like this. Input is a sine signal. And what is the frequency of the sine?
The frequency of
Omega. Omega is frequency.
Frequency.
And what is upper
Amplitude.
amplitude, right? And we can rewrite it by Euler formula. And this way, and then this amplitude of final signal omega is frequency. And then if we do Laplace transform, we get amplitude to x in this form.
So for a linear system, describe the transfer function for the general form. We have the numerator and the numerator and denominator. This is the transfer function for the whole system. And how is what? This one. Can we get that? How to do outputs if you know transfer function and let's get to here. So y output equals to the transfer function times input. So correctly. So for the reason of simplicity, assume that GF has different real number poles.
Yes.
And the Laplace transform of the system response can be computed by using our partial fraction extension to yield the composition. Here, GS times input, and we can what? By using partial fraction expansion. This here, remember, Ti j omega is the pulse, and let's repose and you can eliminate this. And you can get it KICIC2. And since the response to a sine wave input can be computed, inverse Laplace transform, we can get this. Okay, if you don't know that process, just try to remember the results. Okay, here. When P, all poles are smaller than 0, the system steady state response is T tends to infinity. So when T tends to infinity, this eliminate, right? Because E, P, I, T, this will be nearly 0. 0 times K and 0. So it no longer exists. When T tends to infinity, the whole response, the output, just the form of this. That is to say, see, the form of this is still a what? A sine wave. That is to say, if you give a system that you put in the sine wave, output will also be a sine wave. Clear? So if we do Laplace transform for yt for output, then the output has a Laplace transform to this. Still a what? A sine wave. So that is to say, here we have an system. We give it an input sine wave. We will have output also in sine wave. See the curve showing here. The black curve is what? Input. The red curve is what? Output. You see, since IT input is sine wave, the output white is still sine wave. But what is the difference?
That's the limit. Each one there's the peak of the inputs is higher than the output. The output spans in a long range of time. No, I guess because the inputs start.
Okay, let's see. Evaluate GS at S equals J omega yields a complex number which can be represented conventionally by its magnitude and phase in columns of the impedance. So this is the transfer function, right? And you let S equals J omega. And then you will find it in this way. This is what magnitude or G J omega. This is the phase. You can write it to e to the power of j pi omega. Pi is the phase. And if we draw it in what? Polar coordinates. And x-axis is real axis. And the y-axis is imaginary. So R here, the real part of GJ omega, the real characteristic. I is what? The imaginary part of GJ omega, the imaginary characteristic. And amplitude of GJ omega is the value. Is what? The amplitude frequency characteristic is this, the length of this, right? And phi omega, the phase of GJ omega is what? The angular S and the G, J, omega. Omega is what? The same thing with the amplitude. So this is how to, if we write it in a polar coordinates, we have the real parts and the imaginary parts. Then the amplitude equals to real part squared plus imaginary squared square root right? And a omega can write y omega over a. And the phi omega, the angle here, arctangent, right? Arctangent, imaginary over real part. And the phi here is phi y minus phi I. Phi is what? The input phase. Phi y is output phase. So the transfer function phase equals to the output phase minus input phase. Okay, let's go back to here. See, if the input system, the input signal has a that is shown here. Remember the input I. What is the frequency of that? Omega, right? By inserting it into GS, we get Y. So what is the frequency of the output? Still omega. So if you insert the system assigned with frequency omega, you will get the output in the sine form, and also they have the same frequency. Clear? But what is the difference? Amplitude changes. Amplitude of the input signal is what A upper A. But now becomes Y. The amplitude changes, and what changes? The input, the phase of the input is what? Zero, right? But the phase of the output is what? It's phi omega, and writing here, right? Phi y omega. So conclusion here: if you insert in a system a sine wave with a amplitude, omega frequency, and phi phase, then you will get output curve in a sine wave, but with different amplitude and different phase, but same one, same frequency. Okay, let's see. Here's an example. To determine the frequency characteristic, we consider the transfer function as here. What typical limit it is? Yeah, inertial. So T is what? Tan constant and K is proportional or gain. Then how to get GJ? What is frequency characteristic? It's let S equals J omega. Let S equals G J omega. Then G J omega means what? G J omega is called the frequency characteristic. And you should get amplitude, phase, amplitude for the output, for the transfer function, right? Okay, here, then the first step for this is what? Yeah. Let S equals J omega substitute into GS to get J omega. And split J omega into real and imaginary part. Then how to show here. First, J omega K still K, Y 1 still 1, T still T, but S changes to J omega. And from here, I want to say J is a what?
Complex number.
Complex number. And J, the constant, the coefficient J is the imaginary part. But since J is in the denominator, can we just directly to know the real part and the imaginary part? We should do what? Yeah, here. You want to get the real part, plot and imaginary part with J. Then how to change this into two parts?
Fine.
Times what? Times 1 minus j omega t, right? So this becomes y plus j omega t times 1 minus j omega t. And here is what? Y squared minus 1 j omega t squared, right?
Yes.
And this becomes what?
K
Minus
J omega
a minus
J omega
j omega. 1 over 1
squared minus.
j squared is minus 1.
Yes.
So this should be plus here. Minus 1 plus j squared. J squared is no longer exists. Plus omega, right? So which part is the real part?
K
Then which part is the imaginary part?
J
Right? So you can write real part and the imaginary part.
So actually the one that is minus is the imaginary part. The one that is negative
Mm.
is the imaginary part. The negative part is the imaginary part.
Yes, good.
Yes. Always is like,
Yeah.
it's the kind of case we're already.
So here the part is what?
Now she, if it's always negative, but it's easy.
Imaginary.
No. It's not.
Minus and one.
The J is a what? It's a symbol for the imaginary part. So minus this part means this whole part comes the imaginary. So this whole part is the imaginary part. If here is a plus, then the plus is the imaginary. So here, since we have a minus here, so you should conclude minus into imaginary part. Okay? Clear? Okay. So real part is this part, and minus this part is imaginary part. According to the formula, can guess amplitude.
Yes.
Amplitude equals to what? Real parts.
Real part minus imaginary.
No. Take it over.
Divide.
Okay.
Oh, this is Pythagoras.
Yeah. See, this is a triangle. So you know this, you
Yeah.
want this. Clear?
Yes.
Just calling to what do that mean?
Pythagoras is good.
Oh, okay. In Chinese, go ding is father, go father Chinese. Okay, we have this, so we get a omega equals to this, right? And this is the final question. How about this?
Is yeah.
Imaginary part of.
Still this triangle. If we want to get rid of this, it's argument this over this. This is imaginary. It's real part. So yeah, this line is very important.
Yeah. Very good.
So arctangent imaginary over real. So we get this over this. This still have minus omega t here. So we have the frequency characteristic already in this correct.
Yeah.
And we get the amplitude and phase. So done.
So now the problem, the question I have is when we have k over 1 plus t j omega, what we need to do is we need to factorize j out.
Yeah.
So we factorize J out, that part is much bigger.
Yeah,
The one without the J is.
a part constant.
Yeah.
That part is imaginary. Okay, how about this? This is the second order system, right? So things become complicated.
Yes.
Because if you substitute J omega here, then how to get J out of the whole? Yeah. Let's see. First, how many zeros?
2.
Zeros.
0 is 1.
1. Minus 1, right?
Yes.
How many poles? 2, right?
Yes.
Minus 2, another is minus 3. So that we can rewrite it into the form like this, right?
Yes.
And substitute S equals J omega to this. We have this. According to computation rules of complex numbers, you learn this complex number. Have you ever learned this? High school. Okay, we told you try to. So, according to the rules of complex numbers, if you calculate for the amplitude of J omega, then it is the what? Result for each part. Each part what? Amplitude time together. Let's see, for numerator, this what is the amplitude for this? Real part 1, right?
Yes.
Imaginary part omega.
Yes.
So for this part, what is the amplitude? Real squared plus omega squared root.
Yeah.
Right?
Yeah.
For this part is what?
It's JW squared.
2 squared plus omega squared root.
Yes.
And this part is what? 3 plus omega squared root and times together. So, and how about the face for it? What is the face for this part? Arctangent
And then
omega over 1.
over 1. Yes.
So it's arctangent omega. It's listed in numerator. So actually it has a plus here. Since these two parts are listed in denominator, we should write minus here.
Yeah.
And how about this? What is arctangent? Omega over 2
Over 2.
minus omega
Over
over
3. Yes. Fantastic.
So these are the rules of complex numbers.
Yeah, long time.
Long time.
It's 2 years ago.
No.
Like 20.
1894. French boy.
It's so long time for you that it's so long time for me.
Yeah, no.
But you should try to do some skills to, if you just do the math by hand and you don't know the rules you can use, then take one.
Yeah.
Now how about this? This is different. Okay, this is give to you and tell you this is a transfer function, okay?
Yes.
And gives you an input determine the frequency response of not the transfer function, not the frequency of the transfer function, but what? Frequency response for output. Then how to deal with this?
Yes.
First of all, whenever you should change S into J omega, right? Because we talk about frequency, the low end J omega, okay? Then first we know y according to the formula. Go long. When have you been? Okay. Here, YT. According to the formula, right? YT equals to A J omega amplitude and sin omega t plus the phase of right? And here we need to first know J omega. What is AI? What is J omega? What is omega? What is phi for output? AI is the amplitude of the input signal. Here. J omega means what? The amplitude frequency characteristic of the system. And omega said with what? Omega is the only thing that
Yes.
so omega is the same. Omega output also. So omega is for this and should also for this. And how about phi?
The phase.
Phase, the phase frequency of the output. Okay, first substitute J omega. We have this right?
Yes.
According to the root number, we have J omega, the amplitude, right?
Yes.
In this one. And phi for J omega arctangent omega minus tangent omega over 2 minus arctangent omega over 4. And this is for the transfer function for system, not for output, right?
Yes.
And how about since we have input here, we know omega is what?
Omega.
Omega is 1.
Yeah.
The constant is t. Frequency. So frequency is 1 of t, okay?
Yeah.
T is time. So omega is 1. To say for the omega, y is what? Which is 1, right? So omega is 1. And we get J omega amplitude is, if we substitute into it, we can calculate this. Substitute omega equals 1 into this. Arctangent 1 minus arctangent 1 over 2 minus arctangent 1 over 4. We get a number.
Sure.
And the phase frequency characteristic. Phase, let omega equals 1.
Yes.
So we have omega equals 1. We have amplitude. We have phase. And then, so that amplitude and phase of the frequency response output of the system are as follows.
Yes.
Since 2 is amplitude of input, so AI equals 2, right? And the phase for input is what? 45
degrees.
Then stick them together. The phase characteristic equals to the output phase minus input phase. And now we want what? Output. So output phi 1 equals to phi omega plus
Input.
and this is 45 degrees. And what is phi? What is phi? Already.
4.4.
So these two summing up, right?
Then
So for phi 1 is 49.4 degrees. Therefore, the frequency response of the output signal is what?
The frequency.
2 times G 2 times J omega sin omega equals 1 T plus this. Clear? No.
You give me late, that's why.
It's fine. I think today's
Yes. I think we have 19 more minutes.
Last
Last minute at 11:50.
No, 11:40 last.
50.
Today's content has been very much.
It's very mindful.
We shall.
if you want to I want content.
No, we need
Last week I stay there and teaching some more mathematics. Maybe you guys make complex numbers.
Deal with the homework, you just hand it, okay?
No more new things first. Review the old knowledge. Let's see. See. Okay, thank you. Let's see. So for first you do the free body diagram. And for point PQ. So it's just a point, no mass.
No mass.
No mass. No mass shown here.
Why?
No mass. Where's the mass? Tell me. Where's the mass?
No mass.
The figure was a little confusing. So I was thinking maybe the middle is
The middle is the
mass.
mass.
The middle.
Now you should take
No mass.
point P
Yeah.
and reference point.
Yes.
Let's do analysis. How many forces are acting on point P? But no mass. It's just a point, no mass, of course. So for the P, first, if the P is moving down, then the spring attachment has a force. This is what?
This BX dot.
So if you
This has still another distance. So minus XO.
Yes, actually, fantastic. Yes,
Of course, right?
of course, actually.
And how about here?
K, yeah. KX I minus X0. Yes, actually, fantastic.
And how about what the force?
K2
Plus X1.
K2 down K2 X0. Yeah, fantastic.
And how to get the
Actually,
if we miss the first
some of
step,
some of us, but it's acting force.
it's okay to make mistakes in homework. It's okay.
Will you give us marks for that?
exam we should actually. We didn't sleep well.
But what is it? It's okay to have.
But it is okay to have mistake, but we get good marks.
Actually, you gotta understand this.
I will go through all your homeworks to see if lots of you have mistakes. Then I will lower the percentage to take into that homework to take into the whole scores for the course.
Actually, is it possible you give us another homework?
We have how many homeworks? Like maybe seven or eight homeworks. So it's okay if you did wrong in one homework, I think.
Yeah,
The
that's
next one that we give, I think we didn't, we were understanding nothing.
That's
I think I just did that.
Okay, we'll start from the first again.
But
Then let's continue.
Yeah.
How to write down the differential equation for this point. These two
plus
equals
yes.
and find for me to see if I get down. Oh,
output over input should be A1 ES A1 plus A2 plus ES.
So, is it possible we start the whole homework again?
No need to do that, I think.
Actually, some of them will be very, very big and
Big
tangling.
mistake.
In fact, sensitive mistakes.
Okay, what's the homework for next chapter?
Hey, now she did.
Uh, 62.
Okay. Okay.
Okay.
Okay, then for this circuit, UI input, UI output, right?
Yes.
How many inputs you can write down? First, for UI equals to what? R times what? L times what? Oh, plus what?
Plus, what's my name?
Right?
Yes.
The voltage of UI equals the voltage across R. The voltage plus a voltage across L plus voltage across C, right? And UO is what? O is what?
You or sharp question concerns this project. This circuit for the circuit part, because I really don't understand. Like for the other one, the one for the physics, I get that one. The one with the
Look, this is Ohm's law.
yes,
The voltage over A over R
yes,
equals to the current times R.
yes.
So this is the voltage, right? And plus what? Another voltage here is the voltage over
Yes.
the volt over L. What's the formula to calculate for the voltage? L d times T.
Yes.
And another voltage is what?
Yes.
So this, understand?
Yes, I understand.
And what is UO?
Constant. Very good.
Yeah, voltage is C, right?
Yeah.
Is the formula. So you can write those two equations. Then what? To Laplace transform. Can you?
Actually, there's something you said about removing the.
Eliminating the units.
Eliminating the-
Okay, here, let's go through this.
Okay.
But using Laplace transform, you have what? After you add equals R. Here is one. What is this? This one's what?
Uh, LS.
Right? And this is upper UO. Am I right?
Actually, why does it become capital I? In the Laplace transform, when you transform I,
Yeah,
it becomes capital I.
yeah, it shows the difference. One is entanglement, another is after Laplace transform. So you guys the lower for the time domain, upper for Laplace transform. So here we have this, right? How about this? Upper UO equals to this is what?
Onwards.
Because this is integration. Integration is 1 over s is in the denominator. But for the derivative, s is in the numerator, right? See then how to eliminate intermediate I. How to? We can substitute, right?
Yes.
From this, we have to what? UOCS.
Mm.
And then substitute this into here and here. Then you will get the equation only about UI and UO.
Oh, yes.
And R and C are constants.
I will see us.
Okay, we can go. We substitute. We substitute together. U is what? U so
yes.
RN
Yes, plus
plus LS
S. Plus
N.
yes.
Okay. So smart. So here we have UI plus UO. This is what? 1 plus CRCS plus
Plus
CS3. So what should be the transfer function?
O over UI. Yes. 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 Oh yes.
Oh shit. My step is wrong, but my answer is correct. My steps are different. Shit. Okay, the result is this.
That's magic. It's a magic.
Mathematics is complex.
No, magic is
If you do your Laplace transfer first and then do substituting, things are easy.
So how we get
Actually, you step are totally different, but the result is the same.
How
That's what taking the function.
and how you do your magic during test.
That's
The most important.
which one the most important. The magic.
Because if someone don't know how to do that, you don't know, stay like that.
Actually, the exam is subjective. Do we have objectives? Choice question.
You mean for test?
Yeah. Are there choice questions?
No,
Just calculation.
yeah.
So choice question true. Actually, you know how I left. I just did.
So for chapter 5, which one?
chapter 5
Hey.
Fine. Easy.
5.2.
But two.
No.
Which one? Easy one. No, actually, try.
So first, what we should simplify?
The first two blocks.
Yeah. G plus
G2 plus G3, right?
Yeah.
Here we have this. We have this. And have feedback.
Yes.
Feedback.
Yes.
And this is right, right?
Yes.
And then we have one here. And another sign here. Still. Okay, first step, simplify two in parallel. Just G2 plus G3. Then how this look? How to according to the model solve the loop.
According to the feedback.
One plus no.
What?
One plus G2 plus G3
H.
H G2 plus
G3. Balashi, I gave G2 and G3 just one. Like
It's fine, it's fine, it's fine.
And then after that, like.
listen.
Yeah.
Open.
Yes.
These and these are what?
Series.
So these total become
Yeah. See, at least he.
and for the whole closed loop become G1 G plus G3
Yeah.
1 plus G2 plus G3 H1 then
One.
Yes,
Yes, that's
you understand how you
I didn't finish that.
Yeah, that's not all of them.
Actually, this might be exam. This might be exam. Yeah.
Wait.
And this
Actually, can read this might be exam. At least we can.
remember that too. I did well. Actually, the same.
But there was a summing point here. There was a summing point before.
This was supposed to be.
and that because you close the loop then it's just
Yeah.
Yeah.
down to oh you should turn
Now you should add.
you mean the one
Should add this again.
maybe not that we say but the hard level is the same. For test.
No, yeah. It's fine. Yeah.
She just add. No,
Just same difficulty level.
Yeah.
Just the rule. You just follow.
Just to check you are only to use the knowledge, but not the math. So I will give you the test that in lots of
Yes.
to check test two.
Yeah. More, you know. Checking.
Yeah, No, my home, I already submitted. For you.
I'll check. Oh, yeah, good. Once again. There's one, there are 2 ways. There's like. Last two last, but
What I learned English and then I thought I to memorize it. One sentence
What, son?
so the velocity is so
yeah,
Six and seven.
yeah, there's lots of things you can say that.
You see, hey, guys, you got it today. The BBT.
you need teach you? Yeah.
Why don't you give me?
Much if you take the course of physics until I started pricing. I think quite interesting as difficult as I think.
Show me the best one that work for you.
It's with you. How can I show the person to do? Oh my goodness. I will send it to the page. But I have to last time.
Then we need to recover the